Okay, course 3, we're doing exponents and powers today. Uh, it makes the brain confused sometimes. We make a lot of simple mistakes, but it's not something we can't get our head around. Maybe you've done a little bit of this before. 2/5, sorry, not 2/5, 2 to the 5th is what I say here. This is the big number we can call the base. Spelled like that. Okay, and then this little number that's up and to the right we call the exponent, or sometimes we call it the power, like the 5th power. So it's 2 to the 5th power. 5 is the exponent. What does 5 tell me? Does it tell me 2 times 5? No. You're going to do that. I'm calling it. Someone's going to do that. It's not that. Is it 2 to the 5th? Like I said earlier? No. It's 2 times itself. How many times? 1, 2, 3, 4, 5 times. We're multiplying by itself the exponent number of times. What's the answer? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So 2 to the 5th is 32. Let's try this again. Base, exponent. What does that equal? 10 times 10, 4 times. So 10 to the 4th, 10s are nice and easy because you just do as many zeros in your answer as there is exponent. I say it's 1 with how many zeros? 4 zeros. What's that number? 10,000. What if I said prime factorize the number 72 and then show the answer as a product of primes using powers? Okay, well, we know how to make our factor tree. 8 and 9 is what I think of first with 72. 8 breaks into 2 3 times, right? We got a 2 here, a here, and a here. And then 9 is a square, a perfect square. 3 times 3, which are each prime. So we used to say that would be then 2 times 2 times 2 times 3 times 3. But we have a lot of repetition there. Could we do this quicker? Could we do it more efficiently? 2 times 2 times 2 is the same, remember back to how we did this, is the same as saying 2 to the 3rd power. Think about that for a second. 2 times itself, how many times? 3, 3rd power. And then 3 times itself, which we don't say 1 time, we just say that's squared. 3 times itself once is 3 to the 2nd. So it's not times itself twice, really. It shows up twice. Like there's 2 3s in this multiplication problem. There's 3 2s here. So we times it twice, but we have 3 2s. And we times it once, but we have 2 3s. Okay, that's the same as 72, shown as a product of primes, 2s and 3s, or with exponents, so it makes it less wordy. Okay, don't let this scare you. There's a lot of repetition. So instead of showing 2x times y times y times y times z, we show 2, the constant, and then we just show each variable once with the corresponding exponent. How many x's are there? There's 2 x's multiply by itself once, so x squared, 3y's, we just count and make it the exponent, and 1z. Notice how I make my z's so they don't look the same as the 2, and I make the 2 so they're easily distinguished from the z. My x's don't look like times signs. Cursive is helpful. Put a line in your z's. Okay, here's another one that a lot of times people get wrong. We're doing square roots, all right? What does a square root tell me? If there's no number here, if there's no index, it tells me what times itself is this number. What times itself? 121 squared, I think, is 11 times itself. So this is 11. If it does have an index, like 3, it's to the third root. So what to the third power gives me 8? Another way to put it, what times itself, showing up 3 times in the problem, will be 8. Well, it can't be very big. I'm thinking it's 2 times itself 3 times, right? So the third root of 8 is 2. Fair? Sorry, dropped my mouse. Fair? So we can say with this first problem, this one right here, square root of 25 is how I say that. Under the radical sign is this check mark looking thing. Okay, that's the radical sign. We call this square root of 25, and the answer is 5 because 5 times itself is 25. The cubed root, or the third root of 125, so we can say square root, we can say third root, or we can say cube root, is 5 because 5 times itself 3 times. That's 125. The number under the radical sign, like the 125, the 25, those are called the radicand. Lots of terms here. This little 3 is called the index of the root. Third root or cubed root of 27. That just means what times itself, where it shows up 3 times, right, will be 27. 3 times 3 is 9 times 3 is 27. So 3 to the third is 27. Example 6. The floor of the square room is covered with square foot floor tiles. Square foot meaning they're the same on both sides. If 100 tiles cover the floor, how long is each side of the room? The side length of the square is the square root of the area of the square. Therefore, the length of each side is just the square root of the area. Square root of 100 square feet. That square root is 10. Name the first 3 counting numbers that are perfect squares. A perfect square is a number that's a square of a counting number. 25, 9, and 4 are perfect squares. The first 3 counting numbers that are perfect squares, well, 1 is 1 times 1, 2 doesn't work, 3 doesn't work, but 4 is 2 times 2, and then all the way up to 9 is 3 times 3. We could have found that quicker by just going, what's 1 times 1, what's 2 times 2, and what's 3 times 3. Those are called the perfect squares. Let's do all the lesson practice because there's a lot here. It's a little more new and easy to mix up on.